Okay, for what we have moving along with matrix operations, if we look further into finding the product of matrices, and we can say we have like for general sake, we have expressions where we have between the matrices that we have for A, and we'll say we have is equal to set of expressions A of 1, A of 2, all the way out to A of n. And we'll say that we have matrix X is equal to where we have x of 1, x of 2, all the way down to x of n. Once we take the product of these particular matrices, okay, you have the product is going to be a times x is equal to a of 1, x of 1, a of 1, plus x of 2, a of 2, all the way out to where we have x of n times a of n. And the number n will be the same for what we have for a as well as x. And let's say that if we have an example of multiplying two matrices a and x, and we'll say that a will be 1, 2, 3 across, and we have running down, we'll say that we have x is equal to -1, 4, and 7. And a is going to be a 1 by 3 matrix, x is going to be a 3 by 1 matrix, and here we have the number of columns in A to be the same as the number of rows in X. And for M times P, the outside terms, the size of A times X is going to be a 1 by 1 matrix. So that is going to consist of just one term. And just referencing what we have for the algorithm, and we'll say that we have A of 1, A of 2, and A of 3 will be the set of terms we have from matrix A. And for what we have for x of 1, x of 2, x of 3, okay, we have those values as we run down the column values for what we have in x. Okay, so you have x of 1 is -1, x of 2 is 4, x of 3 is 7. And if we multiply respectively and putting in matrix form, encapsulating a of 1, a of 2, and a of 3, okay, so got -1 times the matrix of 1, 4 times the matrix consisting of 2, plus 7 times the matrix consisting of 3. And with the products, okay, so you have -1 plus 8 is 7, and we have plus 21 comes out to 28. Thus the product AX is going to be equal to 28. And let's say that if I expand the model and say that A is going to be a 2 by 3 matrix and X is going to be a 3 by 2. Okay, so in this case, we can take the product, okay, since n is going to be at 3, and the size of AX this time, we have m by p, that is going to be 2 by 2. And looking at what we have here in terms of how we're going to initiate the process to be able to work with the algorithm, what I'm going to do here is that for what I have in X, I'm going to take each column and multiply by A. So just in the setup that we have here, so if I look at the first column from X, and I'm going to multiply by all of matrix A. So we have for x of 1, A of 1. Okay, so x of 1 is at -1, x of 2 we have at 4, x of 3 we have at 7. Now for A of 1 is going to be all of 1 and -1. So we have the A's, okay, this being column formation, so you have 1, -1, and I have plus 4. A of 2 is going to consist of 2, 0, and we have 7 times A of 3. That's going to be all of 3 and 5. And if I look at distributing, okay, so you got -1, 4 times 2 is 8, -1 plus 8 is 7, 7 times 3 is 21, and 7 plus 21 comes out to 28. Then for -1 times -1, that is a +1. 4 times 0 is 0. 7 times 5 is 35. 1 plus 35 comes out to 36. So A times the first column set we have from X, that will come out to 2836. And if I take the second column in X, which will have the values of 6, 5, and 4, and if I apply 6, 5, and 4 over, again, A of 1, A of 2, and A of 3, just like I did working with -1, 4, and 7 just moments ago, I'm going to have 6 plus 10 plus 12 comes out to 28. Then I'm going to have -6 plus 0 plus 20. That's going to come out to 14. And so we got a 2 by 2 matrix, and this will be formed by clustering together the products. So you have A x of 1, we have 2836. A x of 2 comes out to 2814, and just putting together, so the overall product, we have first column, we have 28 and 36. Second column, we have 28 and 14. And so that will be our product matrix. Okay, and looking at what we have, say we have 3 given matrices, and we have that A is given as 0, 1, 2, -2, -3, 4 among the rows. For B, I have -1, -2, 3. For the first row, second row, I have -4, 3, and -2. And for C, I have a 3 by 3 matrix. The first row consists of 5, 6, 4. Middle row, we have -2, 1, 0. Last row, we have 7, -1, and -3. Now, if I look for the product of matrix A multiplied by matrix C, where I have A times C, and we have for the setup, okay, A, again, is going to be a 3 by 2 matrix. We have 3 rows, 2 columns. C, we have a 3 by 3 matrix, and already N is not the same in matrix A or matrix C. Okay, so you have 2 for N in A, which is not equal to, N is equal to 3 from C. And since we have an imbalance already, the product of AC is going to result in no existence. So we have no solution. Now, if I multiply B and C, okay, now B, this is going to be a 2 by 3 matrix. C, again, is going to be a 3 by 3 matrix. And for what we have in the case of N, okay, N is 3 in both of the matrices. And so that means that if we have N to be the same in both matrices, we are going to have a resulting product. And the dimensions of BC, M times P, this will come out to 2 times 3. All right, and so we have in the case of the layout, and just sort of carrying over the algorithm we have here. So if I take B and look at C column by column, okay, like B times C of 1, okay, so got matrix B, and C of 1, again, we have 5, -2, and 7, and then taking, again, 5, -2, and 7, and distributing over A of 1, A of 2, and A of 3 in matrix form, respectively. So I got 5 times A of 1, so I have -1, -4, then I have plus -2, and we have for the second A, I have -2, 3. And then x of 3, A of 3, x of 3, we have at 7. And we have A of 3, we have at 3, -2. And combining, okay, so top numbers, okay, the products will add up to 20. Bottom numbers will add up to -40. Okay, so 20, -40 will be the first column in the solution. And then we have next, if I go over to the next column in C, okay, so I still had the same B. And then the second column values from C, I have 6, 1, -1, and letting the 6, 1, and -1 be respectively x1, x2, and x3, and then distributing over the matrix set we have from B. We have A of 1, A of 2, A of 3, and filling in. And we have for the result here, we have -11 and -19. And then for the remaining column, if I take B and multiply by the last column from C, and again we have with the values 4, 0, and -3. And if I have 4, 0, and -3 as the scalars, that will be multiplying each matrix respectively, A of 1, A of 2, and A of 3. The result is going to come out to -13 and -10. And with the 2 by 3, so if I have the first column to consist of 20, -40, the next have -11, -19, and the last -13, -10, it's going to result that for the product B and C, okay, that is going to be our result. Okay, now crossing over, say if we're looking at the product we have from BC, if I multiply by A, so you got BC multiplied by A. Again, the product is a 2 by 3 matrix. A, again, we have a 3 by 2, and guess what? We have N to be 3 in both matrices, and the dimensions of the product will be 2 by 2. And looking at what we have, okay, if I take the product BC and take the first column from A, and again have the x of 1, x of 2, and x of 3 to be 0, 2, and negative 3, and distributing, okay, so you have x of 1, a of 1, then you have your x of 2, a of 2, and then x of 3, a of 3. And if I combine the products from the top and bottom rows, I come out to 17, negative 8. And this is for the first column in the product. Now for the next column in the product, okay, this will come from taking the resulting product of BC and multiplying by the second column in A. Second column in A, I have 1, negative 2, 4. And if I let this be the x of 1, x of 2, x of 3, and again the product BC, again you have your A of 1 at 20, negative 40, A of 2, negative 11, negative 19, A of 3 we have at negative 13, negative 10, and looking at the distributions throughout, and we're going to have the top number product to be negative 10, where we have the sum of the products, okay, for the bottom rows, okay, we come out to negative 42, and piecing together the items. So the product BC, all multiplied by A, will come out to this result where we have in the first column, we have 17, negative 8. And then for the second and last column, I have negative 10 and negative 42. And if I take the same product matrix BC and multiply by C, okay, so again, BC, I have a 2 by 3, and C is a 3 by 3 matrix. Again, this time N is going to be at 3. These are the same. And for the product, okay, you have what's going to be a 2 by 3 matrix. And applying the C first column, second column, third column treatment for C, and multiplying by, okay, BC. So your A of 1 is going to be 20, negative 40. Your A of 2 will be negative 11, negative 19. And your A of 3 will be negative 13 and negative 10. And we have applying the first column that we have from C. Okay, so you have your 5, negative 2, and 7. Your 5 will be x of 1, negative 2 will be x of 2, 7 will be x of 3, and again you have times a of 1, a of 2, a of 3, and multiplying and adding the products together. Okay, the top layer will have 31, and the bottom, okay, will come out to negative 232. And shifting over to the next column in C, okay, where we have x of 1 is at 6, x of 2 is at 1, x of 3 is at negative 1, and running it over a of 1, a of 2, and a of 3, and following through. So we have the result here to land at 122 at the top and negative 249 at the bottom. Again, so the product matrix is going to be 2 by 3. And looking at what we have, taking the first, second, and last columns from C and having those sections to be multiplied by the product matrix BC. Okay, so applying the x of 1, x of 2, x of 3 treatment for first column from C, and we have for this product or the result we have 31, negative 232, and then applying x of 1, x of 2, x of 3 over the second column values in matrix C. Okay, so the resulting product, you have 6 times a of 1 plus 1 times a of 2 plus negative 1 times a of 3. And the result we'll have at 122, negative 249. And we have with the last column from C, okay, so you have 40, negative 3, letting that be respectively x of 1, x of 2, x of 3. And again, we have a of 1 at 20, negative 40, again, a of 2, still negative 11, negative 19, and a of 3 we have negative 13, negative 10. And looking at taking the products and adding together, and we have the top number comes out to 119, and the bottom number comes out to negative 130. So looking at putting it all together, okay, so we got 31, negative 232, 122, negative 249, and finally we have 119, negative 130. And again, the product is a 2 by 3 matrix.